So there are those points, and then we're going to switch, I'm going to switch to pink, and we're switching to the Y2 column is where we're going to get these values from. So when X is 3, Y is 7, and when X is 4, Y is 9. Plot those points first since I'm already using pink. 3, 1, 2, 3, 4, 5, 6, 7, and it's off the graph, unfortunately. So 5, 9, if I estimate, would probably be right about there. Negative 4, negative 4, negative 1, 2, 3, 4, 5 is right here. Negative 4, negative 3, negative 4 is here. Negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, and then 2, 1. Now, there's one more important thing I want to talk about here. We need to actually see where 2 would be if we were to use our second function. Okay, so when X is 2, if we were to use the second function, 2 times 2 plus 1, that would give us 5. So, before the point 3, 7, we would have the point 2, 5. Now, if I put the point 2, 5 here, 1, 2, 3, 4, 5, it's going to cause us to fail the vertical line test. So what you have to do is put an open circle here. Say this is where it would be, but it doesn't really exist there. When X is 2, it's 1 because we use the first equation. So we draw our first part of our function like this, and your second part of your function like this. And then 4. Are they functions? Yes or no. They're functions if each x has exactly one y. So A, 0, 2, 4, 2. These 2's repeated, so no, this is not a function. B, there are no repeating x values. So yes, it is a function. C would fail the vertical line test right there and in a bunch of other places, so that is no. But D would pass the vertical line test anywhere you draw a vertical line. Every x maps to exactly one y, so that would be yes. Okay, now we're going to move on to page 39. So you're going to skip a few pages. We're going to come back and work on these together. And we have some more practice with all these features of a graph. Okay, so we're starting with giving y values for x values. G of 1, where is our graph when x is 1? Right here. That point is 1 for x, and then negative 1, 2, 3, 4, 5 for y. So that's our point 1, negative 5. So G of 1 equals negative 5. G of negative 4, where's our graph when x is negative 4? It's right here, and that is the point negative 4, negative 4. So G of negative 4 is negative 4. And then G of 0, x is 0 right here, and the y value there is negative 4. And that is actually the y-intercept. 0, negative 4. It's where the graph crosses the y-axis. Where are the zeros? That's where the graph crosses the x-axis. And that happens when x equals negative 2, so negative 2, 0, and x equals 3. So 3, 0. The relative minimum, well, a relative minimum could be this point right here. It's a turning point, it's a low point, but it's not the lowest point. So that's a good example for a relative minimum, and that is at negative 4, negative 4. But the absolute minimum is the absolute lowest point, and that's right there that I marked at 1, negative 5. There's a couple of different relative maximums because we could use the starting point, but I'm going to use this turning point right here. And that's the point negative 2, 0. So it's a maximum value, it's a high point, but it's not the highest point in the entire graph. That's right here at the point 4, 5. Okay, so I color-coded all of that, but when I go to do the domain and range, I'm going to erase what I have on my grid, so you can rewind back to see those colors and me redo that if you need to. And the domain is your X values. So we're going from left, actually I didn't want to do that color. We're going from left, the furthest point left, which is right here, to the furthest point right, which is right here. The X values from here to here is your domain. Those are your possible X values. So what's our X value where it starts? All the way to the left. 1, 2, 3, 4, 5, -5. What's the X value where it stops? All the way to the right. 1, 2, 3, 4. We use an inequality, so our domain is -5 is less than or equal to X, which is less than or equal to 4. And those equal signs are important. For domain and range, you always have less than or equal to signs because the function does exist at these points. So they need to be included in that inequality because they are part of the domain. Okay, so now range, we're looking to go from the lowest point to the highest point. And that gives you your lowest possible y value, which is right here, when y is -1, 2, 3, 4, 5. And your highest possible y value here when y is 1, 2, 3, 4, 5. So our range is from -5 to +5 for y. So that's -5 is less than or equal to y. Be careful, make sure you use y because we're talking about y values, which is less than or equal to 5. All right, interval where we are increasing. Well, we're increasing in a couple of places. I'll point out where. We're increasing here and here, okay? So you can give either interval. I'll give you both so you know. We're increasing from this point to this point, which is when x is -4 to when x is -2. So in the interval, -4 is less than x is less than -2. Now, we don't have equal signs here because if you're at the point -4, you're not increasing or decreasing. Same with that -2. You're standing still, about to change your direction. All right, we're increasing again from here when x is +1 to here when x is not 3, 1, 2, 3, 4. So that would be from when 1 is less than x is less than 4. And I'm going to shade those areas in so they stand out to us. So this is our first area of increasing, and this is our second area where we're increasing. And you can see in your graph that leaves two areas where you are decreasing. We're decreasing here, and we're decreasing in here. Check it out. Here, you're going down, and here, you're going down. So, what are our x values in this first little area where we're decreasing? We're going from here to here. That's just one unit from -5 to -4. So we are decreasing when -5 is less than x is less than -4. And then we're also decreasing again here at -2 to here at 1. So that would be -2 is less than x is less than 1. And the last thing I want to talk about is positive versus negative. And I'm going to take my graph and I'm going to highlight in green everything above the x-axis. That would be positive. And in red, I'll do everything below the x-axis. And that would be negative. And so where is our graph positive? Well, I don't see the graph anywhere above the x-axis except for here. Okay, so our graph is only positive here from when x is 3 to when it ends when x is 4. So you'd say 3 is less than x is less than 4. It's negative where it's under